In the land of flipped mastery, legend tells of the hardest math problems imaginable, and the answer for X that would give power to enslave the world. It has been sought by many and has found its way to the most unlikely student possible. X must be found.
I cannot do this alone.
This task was appointed to you, and if you do not find a way, no one will.
The enemy has many spies. Birds, beasts.
Something draws near. I can feel it.
Hello there, and welcome to your next lesson in pre-calculus. This is Mr. Bean, and we're going to be talking about limits to infinity. So to start us off, we're first going to look at comparing horizontal and vertical asymptotes. So what's the difference? Well, besides the fact that one is horizontal and one is vertical, okay, yeah, that's obvious, some things about horizontal asymptotes. Number one, the graph can cross a horizontal asymptote. Now this is a little trick that most students get confused about at the very beginning. They think that this is some type of boundary line, this asymptote here, and that the line cannot cross it. Well, that's not true. For a horizontal asymptote, it is possible to cross. So you see on this graph here, this is an example of one that crosses and then approaches this line as you go off to the right here. Number two, for a horizontal asymptote, the asymptote itself is showing the end behavior, and that means it's not about what the graph is doing in the middle. In fact, look at this. This is another example of a graph that's crossing a horizontal asymptote. In fact, it crosses it a lot of times. But as you move off to the left, and if you move off to the right forever and ever, it is going to show you what the graph will eventually look like. So it is getting closer and closer to looking like a flat, straight line over here on the right side as well as the left side. So what we do is we call that end behavior. And then the third point is that it is possible to have more than one horizontal asymptote. Usually it's just one, but once in a while you have more than that. So this is an example of a logistic function, which we have talked about earlier in this unit, and we'll get more in depth in those later on in the year. Okay, so pause the video if you didn't get all that written down. Moving on to vertical asymptotes. For vertical asymptotes, the graph will not cross it. It's not going to go past. So what I'm talking about is right here when we're looking at this vertical asymptote, if I'm moving towards it, it's going to not cross it. It's going to either curve up or down, which leads us to our second point, which is that the graph will turn up or down. So I like to think of this as kind of like a boundary point that, or a boundary line. As it's headed towards it, it just kind of pushes it. It cannot cross. Which leads me to why I was showing some Lord of the Rings stuff with Gandalf. Here, take a look at something here.
Hey, welcome to my backyard. I'm wearing one of my special t-shirts that I like to wear on T-Shirt Tuesday, and it has a really cool Gandalf who's representing the vertical asymptote, and the X values are the Balrog, however you say it, Balrog. And so this is basically this is a t-shirt that you have to be a geek on many levels to understand.
Cool t-shirt, eh? Isn't that fantastic? I look so awesome when I'm wearing that thing. Okay, so then our third point is that it's okay to have more than one vertical asymptote. So you'll have lots of times where there will be more than just one. That can happen with horizontal asymptotes as well, but it is more common with vertical asymptotes. This one here is actually a trig function. We will do this one in the second semester. We'll talk about this graph itself. Now, these 6 things that you've just written down, this is basically like a preview to the lesson that we're about to have. So you might want to refer back to these, and hopefully it will make sense as we're going through. Here we have the limit notation for horizontal asymptotes. Now this gets a little confusing for kids, so first thing I want to do is point out what is going on with the notation and how you write this stuff out. Okay, so, getting a little crazy with my pins here. All right, so look at this word limit. This is an abbreviation for the word limit, and underneath it we have x is approaching negative infinity. Okay, this is where we need to put the x approaches negative infinity. It needs to be small underneath the word limit. And then we have this big f of x symbol equals. This is how we start off with limit notation. All right, don't be putting this x approaches infinity stuff all over the place. This is where it goes really small underneath the limit. So what does this phrase mean right here? X approaching negative infinity, f of x equals blank. Well, this is what it is. The left side of the graph, that is x approaching negative infinity. So when you see that little phrase right there, it means the left side of the graph. Now the last part is that f of x will equal, of course, that's a y value. Remember, limits are y values. So whatever our answer is here, if I just throw in, I don't know, negative 21, that means as you approach on the left side of the graph, if you go way off to the left, y value is going to get very close to a negative 21. Here we have x approaching infinity, and so x being closer and closer and closer to infinity, that means we're going to the right side of the graph. If we have an xy coordinate graph, we're going way off to the right. So the right side of the graph has a y value that approaches, it's going to get closer and closer and closer to a number. Okay, hopefully that makes a little bit of sense here. Let's do some examples and see if you understand what that means. Which, by the way, this is going to come up a lot this year, so make sure you understand this limit notation. Now for these examples, you're going to need your graphing calculator, so please grab that. If it makes it much easier if you can do it with me as we go through this lesson. And the first thing is, let's bring it over here. Voila. Okay, now let's plug in example number 1 into the y equals. Okay, I've got some stuff there, so I'm going to clear that out. And now I'll plug in this function. Well, a common mistake is that students incorrectly type this in, and what we want is 3x minus 4 in parentheses because we want the entire numerator in parentheses. So that whole expression there, 3x minus 4, is now being divided by, and again, not just by x, but we're going to divide it by x plus 1 because that whole thing is in the denominator. Okay, so be careful about how you set that up, and now we'll hit enter. All right, so we're going to graph this thing. In fact, I'm going to jump straight to a standard window. So before I even hit graph, I'm going to hit zoom. Option number 6 here is a standard window, so I'll hit 6. And there we go. Here's my graph. So what is the horizontal asymptote? Again, I'm not worrying about vertical asymptote in this part of the notes, just horizontal. Well, how do I get that? You could hit trace, and you can start moving along here, and you can see as we move off here to the right, you could start to figure out what the x value is. Okay, so it looks like 2, and then it's getting bigger than 2, and I could just keep hitting right, and then it'll continually scan over a little bit for me, but that's going to take a while. So what we can do to speed this up, there's a couple ways of doing this. One way, so I want to teach you both. One way is we're going to change my window, and let's have the x max be really big. How about we say that's 100, 1,000, 10,000, 100,000, how about a million? Let's plug in 1 million to the x max, and that's going to make it so that I go way, way, way out here to the right. Now when I hit trace, okay, you see this? I'm off here at almost 500,000, and so it's 2.999986. Now that helps you know what is the y value approaching as you go off here to the right to infinity. It is approaching a y value of 3. Never actually gets there, but it's getting close. So now we go back here. Actually, hold on. So let me just grab that and drag it over here so then I can kind of refer to that and remember what it was I was talking about. And let's now write in limit notation. We're going to write down the limit as x is approaching infinity of the function f of x, it's getting a little sloppy, is equal to 3. Okay, and this right here is talking about that the right side of the graph is approaching a y value of 3, and that is the horizontal asymptote on the right. But it does not necessarily mean that that's what's going on the left side, so we need to check both. So what I'll do is on my window, I'm going to type in a negative 1, 0, let's see, 100,000, 10,000, 100,000, and there's a million. Let's plug in a million to the left for my x min and graph that puppy, and it's going to come up here. Oh, and by the way, if you ever see these little tick, 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 tick marks that we're counting right there, if you get stuck on that screen, a nice little trick, sometimes it happens with these, is you just come down here and hit the on button. It breaks it. It just stops. It stops your graph from graphing anymore. So you can always do that just if you're getting stuck on your screen. All right, so let's see here. We want to go trace, and now let's go off here to the left. And as I move to the left, you can see what is happening. Now I'm counting up pretty quickly because I'm going to a million very fast. And you see these y values here? The y value is very quickly getting closer and closer to a value of 3. Now it's not going to get there, but it's going to get awfully close. So we come back here, and now, here, I'll just drag this over. There's my left side. And let's write then, describe the left side. So the limit as x is approaching negative infinity, and that's how we talk about the left side of the function f of x, and then that also equals 3. So there is the horizontal asymptote for that function. Okay, here on the second example, I'm going to show you a different way. Instead of just using the trace button on the graph, which is a good way of doing it, I'm going to show you a different thing here with the table. So let's go to y equals. I'm going to clear that stuff out and type in our new function. So we have 2x squared. Now for x squared, I just do xx. It's easier, faster for me. So that's how I do x squared. It's okay if you want to just do the x squared yourself on the calculator, but I like that one. Plus 3x minus 805, and I'm double checking to make sure that I put the whole thing in parentheses. That's the numerator.
Divide by, and open up the parentheses, 3xx, that's pi squared, minus 75x, plus 1007, and
close the parentheses, enter, and there I've got it in. All right, now so if I do a zoom 6 for a standard window, and what do I got here? All right, let's see what's graphing, and I don't really see very much. Well, what's going on? This is where maybe you have to play around with your windows a little bit. So, I mean, I could just zoom out, hit enter. I did a zoom 3, and that still doesn't work very well. Okay, I can kind of see something's happening here, something's happening there. I don't really know exactly what's going on. But if you remember, we're only looking for the horizontal asymptote, so it only matters way off here to the right and way off here to the left. So we could go into the window and change our mins and maxes to be very large, very small, and very large numbers. But there's another way to do that, and that's with our table. Watch this here. If I do a second in table set, so I'm going to set up the table. Let's start, well, we can start at 0, but let's change by, let's do 5,000. Then when we go second and table, you can see here that the x value is going 5,000, 10,000, 15,000, and then this very quickly helps you to see what is the value, the y value approaching. And you can see it's 0.66. There's 3 sixes. Ooh, 3 sixes. That's a bad number. Okay, keep going. And you can see it's just going to kind of, it's starting to slow down. But what's this? 0.66 and then it's 7.3. You can get an idea of what it's approaching. It is getting closer and closer to 0.6 repeating. And so the horizontal asymptote as you move off to the right would be 2/3. All right, so let me drag that over here. So that's going to represent the limit as x is approaching infinity of this function f of x, that equals 0.6 repeating, which is the fraction 2/3. All right, so that's how you do this with a table and not having to use just a graph. Well, how about the left side? Let's go back here and set up my table. This time, how about I start off at negative, really big number. I don't know, let's just type in a bunch of zeros and hit enter. That would be good enough. And then second table, and there we go. See that? I went that -1 e to the 8, that's scientific notation. And so this just represents a very, we say large negative number, which really means a very small negative number. So -1, 0, 0, 0, 0, 0, 8 zeros after that. All right, so that is also 2/3. Simple enough. Let's come over here. I'll bring that over so I can remember it. And let's type out our limit notation for the left side of the graph. So we say the limit as x is approaching, now the left side is going to be negative infinity of the function f of x, and that also equals 2/3. Okay, so again, usually the left and right side are the same for horizontal asymptotes, but once in a while they're not.
Okay, now to number 3. This one is actually a pretty challenging one. You're going to have some like this in your practice and mastery checks, test, all that. So make sure you're paying attention because it is a bit confusing. I'm going to plug this into the calculator, which I already have set up. And right away here, if I go to set up the table, I'm just going to count, start at 0 and count by 500s. And as you move off here, let's look at the table. It's pretty basic. It's going to, the y value we see right away is going to approach 5. So as we go off to infinity, we're approaching 5, so I can go ahead and write that one here on the right side. The answer will be 5, no problem. But what about the left side? If you look at this and you go back up here to the left side, you get this error message. Well, this is where it gets a little tricky. How do you know what's going on? If you look at the graph, you have this weird thing going on like this. In fact, I could probably, instead of negative, let's go negative 500, enter 500. I'm just going from -10 to 10 on the y values. Yeah, you're still not going to see much going on. So it's not an error over here on the left. There's something happening, except then all of a sudden it stops. So what is going on here? Well, this is called a logistic function, and the calculator has a hard time finding end behavior, and this is why. If I were to plug in a number right here, let's focus on just this portion right here. Let's focus on that. So if I plug in a value into x. Let's say I plug in 1,000. If I plug in 1,000 in right there, here's my 1,000. E to the negative 1,000 is the same thing as 1 over e to the 1,000, and that's about 0. 1 over a really big number is 0. So the calculator recognizes that. If we do e to the 1,000 and try and type that in a calculator, you're going to get a really, really big number. Let me show you this. So come back here. So e to the negative 1,000, boom, calculator says it's 0. But if I do e to the 1,000 and hit enter, oh, overflow. There's an error. There's an overflow, meaning, let's just quit that. It's just way too big. It can't handle that big of a number. So there's a couple ways you could do this. One would be just to think about what you're doing, and that is e to the, I'm going to plug in a negative, so a negative 1,000, which is just a positive 1,000. That's super big number. So this thing right here is 1 plus super big. The whole denominator is super big. So it's 9 over super big. That just is 0 minus 4. That whole fraction becomes 0, and then it's minus 4. So that's going to be a negative 4. And the other way, if you want to just play with the calculator to be able to do that, instead of just thinking about the numbers, although it's a good to do the number sense, if you go on the graph, and if you just hit trace, and then we go one step to the left, so you can see here, left, 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 you can see it's right away it's approaching negative 4. You might get decimals for a little bit, but you're going to find it pretty quickly there, negative 4. Okay, that's how you do the logistic functions.
Okay, here we go, limits as for vertical asymptotes. This is a little bit weird because now, instead of going off to the left or the right, we're actually approaching a very specific number. In this case, with this red dotted line, you may not have that on your graph, so maybe draw that in real quick. We're going to approach this exact value. So on this example, the x value right here looks like 1, 2. So I would say that this c is going to be a negative 2 for this specific example for this vertical asymptote. So go back over here. You see this tiny little exponent right there, that minus? Okay, so remember we're talking about the left side of c. So we're going to approach this value c from the left, and in this example that means that the graph would be going down. Now that doesn't mean on every example, so don't get that confused. It's not every single time you see this, but in this example we would say that it is approaching negative infinity. So we approach c from the left, the graph is going down to negative infinity, and this symbolizes that we have a vertical asymptote. Whenever you see something like this, again, it wouldn't be a c, it wouldn't be a letter, it would be an actual number. Now let's talk about the right side. So if we look here, we've got approaching the value of c. The x values are approaching a value of c, and we're talking about approaching it from the right side because we have a little plus there. So we approach from the right side, we're going this direction, and it is getting pushed upwards. And so we say here that is it going towards positive infinity. Oh, that disappeared because I went to a new slide. That's negative infinity. Hopefully that makes a little sense. So when we're approaching a number, that's a vertical asymptote. If we have x approaching an infinity value, that's a horizontal asymptote. So if you didn't just listen to that, rewind the last 10 seconds, maybe get that down in your notes to make sure it's very clear when it's horizontal and when it's vertical. So let's apply this stuff. Now you need to make sure you have a graphing calculator to do this, and you want to do this with me just for the practice of it. We have these two examples. We'll do this pretty quick. And what I've given you here is a big, huge hint, and that is right in the middle. This is going to be our vertical asymptote. So I'm just giving it to you right now. Okay, for these practice problems, mastery checks, all that, we will give you that x is going to equal negative 3. That is the vertical asymptote up and down. So we can plug this whole thing in, graph it, look at it, all that stuff. So take your calculator, pause the video, type that in. And voila, there's mine. That was really quick. And now we can take this thing and we could graph it if we just click on here, graph, maybe a zoom 6, get a standard window, and there's my graph. Now what we're trying to do though is not use the graph to figure out what's happening. Now you notice here there's a vertical asymptote. Let me pull this over here so I can keep referring to this graph. We have this imaginary line up and down right there that it is a vertical asymptote. We don't see it, but that is our x value of negative 3. So what we're trying to figure out is how do we know what's happening around this point? And the only way to do that is to zoom in. Let's zoom in on this. To zoom in and get really, really close to this x value of negative 3. I can't be on the negative 3 value because the graph doesn't exist there. But the closer I am, the better I will know on the left and the right side. So if I'm on the right side of negative 3 and plug in a number, I should get a really positive number way up here on the graph. If I choose a number on the left side of negative 3, but it's very, very close, then you should get a number that comes out a y value of very negative. There's a few ways of plugging in the numbers. One is we could just take this negative 4, negative 3.5, negative 3.1, and just plug it into all these x values, use a calculator and figure out what the number is, and then fill out our chart. Okay, that's probably the way that's most familiar, but it is the slower way. You could also take our calculator, and if you remember here, since I have it in y equals, second quit, let's clear anything out here, and then you could do this little trick we've done before, the vars button, the y vars, the function option, y1, open up a parenthesis, and then we type in a negative 4, and that will plug in a negative 4 into whatever I had in my y1. So in this example, it would be a negative 1. So I come over here, and let's type in a negative, let's use red. Let's type in negative 1. All right, then we could do the same thing with negative 3.5. But there is a faster way of doing it, which is really nice. In fact, I think Mr. Brust has shown this in a video previously, and that is to create a table. Here you have the table button. Here you have table setup. We need to set up our table. So let's do second, and then that button there, and we have our setup table. Now where our tables start and the change in table values does not matter at all, because what we're going to do is come down here to the independent, and the independent is the x variables, and we're going to say, hey calculator, ask for them. Don't do an automatic numbers that you think is good. I want you to ask me what are my independent variables. So then when you do this, and then you come over here to the table, it's now waiting for you. See? Nothing here. It's waiting for you to plug in the numbers. So if I type in a negative 4 to the x, it spits out a negative 1. So nice and neat, and that's what we had on our table before. And then we can type in the negative 3.5 and so forth, and type in some more numbers here. So let me pause and get the rest of these numbers up. And there's as many numbers as can fit on the screen. Now notice it's not all of the numbers, but it's quite a few of them. So I can take these numbers now and transfer them over to my chart. So let's pause the video and get those numbers onto your chart now. Okay, we've got them on the chart. Now let's go back, and we now need to finish up, pull this over. We now need to finish up the numbers that we didn't have. So we've got 4 more numbers. I'll go up here, and if there's already something on there, you can just hit the delete button. The delete button will clear any numbers out, and then you come up and then just type in the new ones. Let me pause my recording and let those magically appear. Okay, there's my numbers, and I have gone ahead and transferred them over to my chart already. So there we have our chart of values. Now here's what's nice about this. Remember how I said the vertical asymptote was a negative 3? We have that here. Well, the closer we are to negative 3, the better we're going to be able to know what is happening around that number. What is the behavior of the graph? So if we look at negative 3.001, you can see that the y value is approaching negative 1,000, which means very, very far negative. So as we approach negative 3 from the left side, it's going to be way down here. And then you have negative 2.99 on the right side of negative 3 is positive, and so we will be going up to positive infinity. That's how these chart values help us figure out what the limit is. So now on our answer, what we'll say is that the limit, and now be careful here, the limit as x is approaching, first we're going to approach the negative 3 value from the left side. So we put a little minus there of f of x. So on the left side, now obviously from the graph, you can just see it's going to negative infinity. The idea is not to have to use the graph, it's to use these numbers. And so we're approaching negative 3 on the left side, and it's approaching negative really big. So it's negative infinity. And then we write the same statement from the right side. You have to write them both. If you leave off either the left or the right side, you are leaving off half of the behavior of the graph. So we now say from the positive side for this little exponent, and then f of x equals, and then we saw here that on the graph it's going up, but what's more important is the numbers. And so we're using these numbers to show that as we get closer and closer and closer to negative 3, then the graph is going up there, and so we say infinity. Okay, not too bad. Now, let's go on and try one more example. This time I've given you the number 10, and I've given you nothing else. So what we're going to do is plug in the numbers that you think should go on the left side and the right side of the number 10. Some of you, don't write this down, some of you will say, okay, let's do numbers 9, 8, and 7, and 11, 12, and 13. Okay, blah, that's a horrible idea. Horrible who thought of that, because we're not close enough to the number 10. Get rid of that. Boop, boop, boop. We need to be really, really close to the number 10. So what's close to the number 10? How about 9.999? In fact, the more 9s you can squeeze in there, the better. And then how about on this side? 10.0001. I don't know, I'm just throwing some
things in there. But that's really close, left side, right side. Okay, now let's go a little bit farther away. How about 9.9? And then this one we could just say 10 point, what's a little bit bigger? 10.1. We could do that. And then here we could go 9. Now we could go farther away. Here we could do 10. So that'll make it obvious. But the big thing is when you're really close to the number 10, make sure you get numbers very close. Okay, so now we'll set up, go to your graph. We need to plug this whole shebang thing in there, and then let me pause and get mine set up. All right, there's my graph. It's all plugged in, and let's go to our table. So let's check the table setup. It's on ask for our independent, so that's good. And now let's go to the table. Ooh, it's got a bunch of stuff in here. How can we clear that? If I go up to the top, it won't let me, so I'm just going to, actually, let's try delete. Delete, that's better. Delete, that works. Delete. Scroll up here, delete. Okay, all cleared out. Now let's do it in order. 9, enter. 9.9, enter. Boy, that's fast. Look how nice that is. 9.9999, enter. What in the world is that? Negative 3.8 e to the 6th? It's a scientific notation. Negative 3.8 times 10 to the 6th. It's a number that is really far from 0, negative. Let's do 10, just to make sure that it says error. Yes, it does. And then I got to move this because I forgot what numbers I said. 10.0001, enter. See, 3.8 e to the 6th, very big positive number. 10.1, enter. Get rid of 10. It's supposed to be 11 right there. There's our numbers. Transfer those numbers to the chart. Pause. Here we go. My first observation when I look at this is I probably went a little too close to the number 10 because 4 decimal places 0.9999. Maybe that was too close because e to the 6 is just, that's 3.8 e to the 6 is super big. Okay, but I guess that makes this obvious. So you didn't need to go that close if you're confused with the scientific notation. All right, let's start off with the left side. So we're going to take x and we're going to have it get closer and closer to the value of 10. We're moving closer and closer to 10 from the negative side. From the left side is what that means. Excuse me. So we take f of x, and that is going to equal, so what are we doing? Are we going down negative, or are we going up positive? Well, this is negative 315, negative 3732, negative 38, blah, 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 lots of stuff, 6 more decimals, 6 more places, I mean. And so that means we're negative infinity. All right, now the other side. The limit as x is approaching 10 from the positive side this time because we're now approaching that way. We're approaching 10. And we have to, don't forget the f of x. So that's the limit as x approaches 10 from the right side of f of x equals, and 451, 3868. We're going up. See, these numbers are kind of going up like that. They're getting bigger and bigger and bigger. So we say infinity. Hey, we're done.
The lesson is over. So at this point, if you want to just jump into the practice, you can. But for those of you who want to make it look like you're still working and just watch something interesting here, this is kind of a fun little video clip at the end. It kind of has something to do with the Lord of the Rings, but I think this guy is hilarious. So we're done. Rock that mastery check, and I will see you back in Unit 3.
You shall not pass! Or don't pass! I'm the guardian of the sacred flame! You shall not pass! You are... Alright, he can pass. Back to the shadows! Shirtless runners! You shall not pass! On, Gandalf, stop the Balrog. You can stop a tourist. You shall not pass! What? That was just dismissive. A wizard can't hear himself work. You shall not have a drum circle! Come on! You shall not... Okay, you're starting to pass. Reflection, perfection. Reflection, perfection. I am the me I want to be. You shall not pass! You shall not pass! Wingardium Leviosa. Gabla Demiosa. You think I'm Dumbledore? You shall not pass. No, no. No way way around.
No way around.
You shall not pass. You shall... I know you guys are enjoying this fantastic and romantic day, but thank you for not passing.
Oh, you're welcome.
I appreciate it.
Are we stuck here forever?
Well, you could go back the way you came. You shall not pass. You shall... Okay, everyone just pass for a while. Then you'll not pass. You shall not pass. You already told us. And you keep passing. Am I stuttering? You shall not pass. Come on, stop passing. Stop. Not only are you passing, but you're doing it exceptionally slowly. In the third age of men, I was legend. Fourth age of men, no one seems to care. You in the green shorts, you shall not pass. You know not to pass. Protecting hobbits, that's what I'm doing. It's not my day. Oh my God. I have lost the hobbits.